Hi, I'm Sri Hamid, Industry Marketing Manager at AVEVA. For food and beverage companies, transparency has become important to the brand promise. Customers want to know more about their product choices in terms of where, how, what, and when they were made. Companies are also seeing value to their own business through improving their ability to minimize risk in the case of recalls. Enabling traceability across the value network, from farm to fork, as they say, can be thought of along two dimensions. One dimension is the end-to-end visibility between the nodes of the network, or what we call internodal visibility. The other dimension is within each node, or intranodal visibility. We need to capture both for traceability, and the challenges can be unique to each segment. In the following presentation, we look at how C&D Foods, a large private label manufacturer of pet foods, implemented a batch management system at their Netherlands plant. My first guest, Adrie van der Sand, who is the shift manager at the Emoda plant in the Netherlands, will introduce the company along with a few thoughts on the importance of product quality to the pet food industry. Over to you, Adrie.
I'm Adrie van der Sand. I work for 30 years here, and this is a C&D factory in Amuiden, Netherlands. And we make about 75,000 tons a year, approximately, dog and cat food in cans. And overall, C&D Foods has 8 different manufacturing facilities across 7 different countries. We in Amuiden make the cans, but in the other factories we make also the pouches, the alu trays, and the snacks, I believe. There are 3 separate factories for the dry pet food with a capacity of 200,000 tons, and the wet where we're in are total at 300,000 tons a year. Now, all plants are licensed by the EU and operate at the highest level of good manufacturing practices. C&D Foods is also an active member of the European Pet Food Manufacturers Association. And yeah, we are very proud that we also can produce for the USA market. We are FDA licensed, and we have a high standard here, not only in also for the way you come in. It's like if you come into a factory of baby food, for instance, where everything has to be perfect and clean. Yeah, it's also here. Well, for most customers, the cats and dogs are the children, their children. So they want the best product and food for their dogs and cats. And so we also improve in that perspective, and I think it's good. Also, the people, the owners of the cats and dogs, they also want a good protein, a good balanced diet. So they also want it for their children, their cats and dogs. And if the cats don't like it, and especially the cats, then they don't eat it. So if they don't like it, they don't like the taste, they don't like the smell, they don't like how it looks, then the cat go away. And so we are doing a lot of that into that to make the right ingredients. And I think it's the same ingredients that for a lot of human food we use. And also the high standards. We are everything smart manufacturing, because we can with our tropos, with our Wonderware, we can go back for 8 months ago to see which pallet of product goes into at what time, at what date, in which products it goes, in which cans it goes. We can go back for 8 months or more even if we want to see it. We can also go back and see every temperature, every pressure, everything we want to know for an hour ago, but also for a year ago or even more. Otherwise, you are sailing a ship in the mist because you don't know what you're doing. And also because you know now what you're doing, But in 4 weeks later, you want to know, what did you do 4 weeks ago?
Thanks, Edri. My next guest is Brian Murphy of Neodyne, who is the project engineer that helped implement the batch system for C&D Foods. He is going to present the project scope in detail, including the plant requirements and challenges and the benefits gained from the system. What Brian lays out is the business case for investment and how payback for a traceability project can be gained through lower ingredient waste, improved sustainability, repeatable product quality, higher throughput, and faster time to market. Over to you, Brian.
Thanks, Sri. I'd like to thank C&D Foods in the Netherlands plant, and they were kind enough to help us to put together the presentation. So thanks, Sri. I'm delighted to be able to represent Neodyne to present a template for the solution on improved batch management and scalability during this webinar. Plant requirements. This is pretty much the same for every customer who's producing food, chemicals, drugs, whatever it is. These are basic requirements that every plant has. But for the plant in the Netherlands, it was just the same. For the C&D Foods Netherlands plant, it was exactly this. These were the requirements of the site. They wanted integration between their ERP system and their shop floor, their production environment. They wanted that integration to take place at every layer. So they didn't want just to have an operator staring at an instruction and then clicking a button on a SCADA, which operated a PLC or a push button system for the sake of argument. They wanted full integration end to end. They wanted the flexibility to handle more complex recipes. In the pet food environment, it's no different than in the human environment, that more complex recipes are desirable. Customers' needs change from time to time. If you think about the people are looking for more eco-friendly solutions for the sake of argument, so the recipes change because of that, or people are sometimes looking for more complex ingredients within the recipe, so sometimes they want more vitamins or minerals included within a recipe for health reasons. And for that reason, we've seen it, same as the human food markets, we've seen a trend towards more recipes and more complex recipes, so more ingredients and more types of processing for the same ingredients. For SCADA integration, they needed full integration with a SCADA system where they were able to see both the recipes and the batch system and how that's working, as well as how the plant environment itself is working. So levels in a tank, or whether agitators are switched off and on, or conveyors are switched off and on. That's equally as important as knowing that the batch is running, that the batch is currently underway and not inhaled or whatever it is. So SCADA integration is actually quite important on that plant. A lot of plants have SCADA integration without a batch system. They also wanted a paperless system so that they didn't have guys walking around and ladies walking around with sheets of paper trying to record what the operators had done on the floor. They wanted the system to be end-to-end digital, so they key in what they have done if they need to. They wanted to adhere to ISA, S88 and S95 standards, but also, particularly in the Netherlands plant, they wanted to adhere to the GMP principles. They want as best as they could, even though they're not bound by GMP principles. And also they have FDA approval to sell food into the United States, which is, it has its own added stringency in terms of ensuring that you're adopting the best standards possible. They also wanted to have traceability of their cleaning systems, so CIPs and SIPs, and they wanted to be able to trace their water usage and their cleaning chemical usage where needed. And they wanted 100% traceability, as we say, farm to fork, and they wanted that on this plant. And I think every plant can kind of sympathize or empathize with these requirements. All of the plants face the same basic challenges as I laid out in the previous slide. The two plants evolved differently. From the start, Plant A began with a batch management system in mind, and it progressed down that route. The plant's coding was done with a batch management system in mind, whereas Plant B started from a very manual standpoint, and they're trying to approach the same end result with a more manual process. So there are advantages to each of the approaches, but we'll try and show you how Plant A achieves the results in a much easier method or a much faster method than Plant B can. And in our experience of working with many large corporations, Plant A would be the aspirational goal of many customers or most customers. And so it would be C&D Foods' goal to make Plant B come towards what plant A in terms of its automation technology and its architecture and everything else. So Neil and I were engaged to devise an automation strategy, for a long-term automation strategy whereby they could reach what plant A had. So they would have full traceability and transparency and reduced waste and all of the good things that plant A has. And as we like to describe it, they will be able to win the opportunities that plant A can already win. Comparing the two plants, plant A and plant B, they both make very similar products. They both make pet food, and they both have an ERP system to guide them as to which batch or recipe to make. And they both have some degree of production scheduling. Although in plant B, it's more manual than in plant A. In plant A, the scheduling comes directly down from the ERP system and is effectively guided by the Salesforce team, who send the schedule of required batches to the production team, and it's automatic in how the production scheduling arrives down at the batch management system. There's seamless integration there between the two. The production team are able to see the list of batches and the sequence that they need to be created in, and that arrives into the batch management system and kicks off production. You've got both batch management and recipe management in plant A, as opposed to plant B, where the recipe management aspect is custom and batch management is manual. Because they've got a batch management system, the reporting is inherent, it's out of the box. Because the batch management system is driving the production on the floor, there's inherently a record created for what was produced, when it was produced, what piece of equipment was used to produce it, the time of, so if it's agitating, you can see what batch it's agitating. You know, that type of end-to-end control and view of the plant floor. Both plants obviously have PLCs, and most plants would have a PLC. And in terms of batch management and recipe management, plant A has a record of each recipe, a master recipe, if you will. It's not at the operator's liberty to modify the recipe on the fly or change the recipe or add in some extra piece of the recipe without it being tracked by the batch management system. The recipe exists in the batch management system. The operator chooses it, selects go, and they can deviate if they have a high enough permission level. They can skip back through the batch, rerun a phase, but they have to log in and it records who has done it. And as a result, there's already a record created, and that record is very indexable. It's all in a Microsoft SQL database, and you can query back in time as far as you like, as far as the records exist in the system, which are infinite pretty much as long as the plant's been around. I don't really need to talk much about SCADA and PLCs, but critically, the plant A is FDA approved, so they can achieve sales in the US market, whereas plant B can't currently achieve sales in the US market. So the benefits in terms of transparency and traceability, I've touched on it in the previous slide, but in plant A, they've got electronic batch reporting. It's not called by something. The something is the batch management system, and it controls both the batch and, as a result, the end batch report. It calls for the batch to happen in the PLC simultaneously as it creates a record of it having called for the batch to happen in the PLC. In plant B, it's entirely dependent on each trigger point being hit by the operator. It's a very different system as a result. In plant A, the batch execution and equipment history associated with the full product genealogy and material traceability, what that's saying in a mouthful is that we have full traceability, not just that the batch has been kicked off on a particular day and at a particular time. We know which piece of equipment it was kicked off in. And for a batch management system, that's a key distinction point between a simple recipe system or a batch management system. In a batch management system, they have the ability to arbitrate between equipment. You could have two lines that perform the same function, and the batch management system will decide to run the production on, or will allow you to decide to run production on one of the two lines that can produce the same output, the same end goal. In plant B, it's a manual traceability process. You need to either have something in the SCADA system or in a push button or whatever you have that says, I'm starting this process on this piece of equipment at this time, or you have a person write it down to say, I started production of batch, whatever, dog food, you know, whatever it is, beef, dog food. I've started that production process at 1 p.m. on line 2. Whereas in plant A, the batch management system automatically inherently records, these are the pieces of equipment that I used to create it. And going further than that, the batch management system not just arbitrates between a whole line and a whole other line, but it allows pieces of a line to be used. So if you have 5 fill tanks into 2 conveyors, you could choose to fill from tank 1 and tank 3 simultaneously into the conveyor and out to the end. And as a result, you get full traceability. If you know what's gone into those conveyors, you know how much has come from each of the conveyors and out to the end product. You know exactly where your originating product is. You're originating whether it be some vitamins or minerals, or whether it be some meat or whatever it is that's going into the end product. You know exactly which original place it came from, which original farm it came from, which original herd in the farm it came from in a lot of cases. So it's very important to have this end-to-end traceability. We call it farm to fork, but it really is. Just in this case, our customers don't have a fork. The cats and dogs who are the customers of this plant. In plant A, that we have digital reports available on demand. And by that, what I mean is the batch management system records the data seamlessly to the database as it does the production. And I've labeled this point probably by now, but the point is you can query that data immediately for any batch at any time. Querying yesterday's batch is the same effort as querying 2 months ago's batch, or the same effort as querying 2 years ago's batch. You don't have to trawl through archives. The archive is the same for every single batch. And so you just dial into your report, I want this day, I want this batch type, and show me the batches that were created of that batch type on that day. And then you've got your full traceability back as well. So you can go, I want to know which dog foods were made on that particular day. And then you can dial backwards which our original suppliers did those come from. It's quite powerful. And Plant B, because they've got an ERP system that records their suppliers, of course, and they've got a system that records that they've produced the dog food, the same as Plant A has. You've got a record at the end of it. But in order to trace it end to end, you've got to tie those 2 things together, and that takes time and it takes effort. And if you need to trace particular types of batch, that's where it gets really messy, because if you're trying to trace all of the dog food with, say, dog food with peas or vegetables or something like that in them, and you want to trace how many times in the last year has a batch with peas or carrots gone out, how many of those batches have we done last week, how many of those batches have we done last year, it takes a long time to trawl through these batch records and then link the 2 together. In Plant A, you just query them by the batch type. You know, you query them by the amount of times peas have been added or the amount of times carrots have been added, and you cross-query it against the batch itself. There's a big benefit in this. It's a commercial off-the-shelf solution from AVEVA. This batch management system is, you can install it at the start and it doesn't need to be modified in order to get your full traceability or transparency for that matter. It's built in, and we have some customers who have dreamt up types of report. I'll give you an example. One of our customers has asked us, they mentioned in passing that they were going through their records of their batches and trying to find out how many CIPs they had run that year to try and get a total of the water quantity that they had used that year. And they had mentioned that they did this every year and they had a batch management system on site. And I said, just query it, just query how many batches. And they didn't realize that they could get that level of traceability from the system. They were able to pull out every CIP that they had run that year. And obviously you multiply that by the amount of water you're using, and you can see your exact water usage just on CIPs per that year. And they were able to make some projects on the next year to tackle their CIPs, the number of CIPs they ran. But not just that, they were also able to bring up some projects to refine their CIPs, to reduce the water usage. Now that they knew how much water they'd used in year 1, they were able to compare that with year 2, and they were able to get a big benefit the next year. There was a big highlight of the amount of water usage in that particular plant, and the team that were able to reduce the water usage per CIP and also reduce the number of CIPs. There's a lot of ways of doing that. They managed to actually save the plant quite a lot of money, and in some cases managed to earn the plant money as well, because by demonstrating their efficiency in terms of CIPs, they were able to win more projects or batches from their parent company. So their parent company would go down to all of the plants and say, you know, how many of this batch can you make us per year? They were able to come back and they were able to tell the parent company that they could make their batches cheaper, they could make them with less water waste, and give us the opportunity. And so they won more opportunities from the parent company. In terms of reduced ingredient waste, the batch management system is responsible for the ingredient addition. It's not an operator manually adding the ingredients in most cases, although you can configure it to allow manual additions to batch management system if you've got sensitivity about the ingredient in terms of whether it really changes the flavor or whether it's a very expensive ingredient. You don't want to leave it at the behest of operators to manually add it if you've got the choice. So batch management system allows you to control the ingredient addition. You have it as part of your recipe. Say if you need to have 10 kilograms of flour or 10 kilograms of whatever ingredient going into the batch, it's part of the recipe itself. It's not waiting for the operator to go down and add it in. And the batch does not continue until that ingredient has been added. So if your chemists or your quality lab say it would be better if we added flour later in the batch, you can change the recipe. You're not depending on all the operators getting the memo. You change the base recipe, it makes it down to the operator, and you can have two of that recipe for the sake of argument. So the quality team might say, you know, for 50% of our batches, let's try and add the flour first. For 50% of our batches, let's add the flour last. And you can compare the two recipes. You can create a copy of the recipe and compare the two. So you have precise ingredient addition, and also the timings of the ingredient addition can be played with. So that's the real benefit of automated control of ingredient addition. And I've mentioned in the slide that expensive ingredients are added in exact quantities only, ensuring high product quality. And what I'm getting at with that is, in our experience, operators are quite generous with their addition of product. So they want to make sure that they don't have a quality issue. So particularly with the expensive products, if you can imagine you've got a cereal with some fruit, dried fruit in it, and you've got, say, bran flakes with dried strawberries in it or something like that. The dried strawberries are the bit that the customer is going to notice. And if you've got just a couple of freeze-dried strawberries in there, they're not going to be too impressed when they go and pour their cereal out. It's pretty much all bran flakes. They go, right, I've been shortchanged here. So operators are mindful of that, because operators are also customers in their own right of all sorts of products, and they're generous with the product. They're generous to have those expensive ingredients, the bits that the customers like, and as a result, they make sure that there's lots of that expensive ingredient going into the batch. And the best way to avoid that costing your plant money by every batch costing more than it should, it's much better to control the addition of ingredients. It's not to be stingy, it's not to cut down how much ingredients are added to the batch. It's the opposite. It's to make sure that the right amount of the batch, the right amount of each product has gone into the batch to create the batch. And that's what I'm getting at with the no waste of expensive ingredients. It's very important, actually, and you could find that you change the composition of your batch by manual additions, and by not controlling the manual additions very carefully. You could completely destroy your margin on the batch, or you could change the flavor to such a degree that your batch is unrecognizable from what your core product is. So precise ingredient addition, it seems like a no-brainer. And in some plants, what they simply do is weigh out the ingredients, and the operator signs off that they weighed out the ingredients, and they manually add them to the batch. That's okay if you've just got one or two ingredients, but as I've said previously, batches are getting more complex. More ingredients are coming into batches, and that's across both the human food chain and the pet food chain. So the batches are getting more difficult for operators to just be manually weighing the ingredients into the batch. And so having precise ingredient addition is very important. Increased throughput. Because the batch management system has automated scheduling of batches, you're not requiring the operator to go in and manually schedule the batch one by one. You're not requiring the operator to check that the equipment is clean or dirty before they run the batch. It's all managed by the batch management system. Batch management system checks that the equipment is clean before it tries to allocate it. It won't allow allocation of dirty equipment. It also allows you to select from, I think I said it previously, where you've got 5 tanks to start with. It allows you to select from one of the tanks that's available for selection, rather than waiting for another batch to finish with tank 1. We go, hang on, tank 1 is already in use, I'll go to tank 2. I know of some plants where the operators literally walk through the tank farm looking for available tanks to fill from. That doesn't happen with a batch management system. The batch management system decides which tank to fill from. If you've got say 5 tanks of, let's just call it water because that's used in a lot of batches. If you've got 5 tanks of water and tank 1 happens to be empty, the batch management system notes that and doesn't try to fill from it. In a plant without a batch management system, it's quite possible that the operator will try and fill from tank 1 and then go, oh, there's no water coming into my production equipment, and then decide to go to the tank 2 or tank 3 or whatever it is. So as a result, in that scenario, tank 1 or 2 could be idle for quite an amount of time, or you could have the next piece of equipment could be idle for an amount of time. With a batch management system, if the equipment is available for use and anywhere else in the plant can be using it, the batch management system will decide which piece of equipment to use when it can use it. And as a result, that equipment arbitration is a real benefit of the batch management system. It's not just some minor aspiration, rather than the operator having to choose the equipment and check whether the equipment's being used recently as well. That's an important detail for most plants. You don't need to check with a batch management system whether it's clean or dirty is built into the system. And in terms of the adherence with the production schedule, this is something I've already mentioned previously. You're not at the behest of operators who want to have a nice milestone at the end of their week. I kicked off 100 batches this week. Yeah, but they were all €1 batches. And whereas you want to make sure that the schedule is adhered to, in a batch management system, there's full recipe scheduling and it follows consecutively. So batch 1 is done first, batch 2 is done second, and so on. In terms of a shorter time to market, this is where the ability to manually configure a recipe above the PLC level is extremely important. For plants without a batch management system or a recipe management system, it's impossible to change the recipe on a whim. And that might sound like something that's a very rare and unusual requirement, but you would be surprised how often it comes up once a batch management system or recipe management system is available in the plant. And what we find, for the sake of argument, if you take the example of making a cake, you get flour and you might get eggs with the flour, and maybe you're going to mix in some chocolate into that, and then you're going to put the whole thing in a mixer. And then the mixer, you take the contents of the mixer and you put it into a baking tray, and then the baking tray goes into the oven. But how about if I were to tell you we're going to take it out of the oven again, and we're going to do something like an extra layer on the top of the cake and then put it back in the oven again? How difficult is that in your current plant? How difficult is it to take something out of its current position in the recipe, do something else, and then put it back in? So for the cake baking example, if you had flour addition, then egg, and then chocolate goes into it, how about I say, no, we're going to add a little dash of water to that? How difficult is that to do in your current plant? If you've got it all within the PLC, you're going to need something like an automation engineer, and you're going to need a lot of sign off in terms of how the recipe was changed. Maybe you're going to make a second recipe for this slightly different system. In a batch management system, you simply create a new recipe up at the upper level on the batch management system. You change the recipe on the batch management system. It's totally separate from your existing recipe. You leave your existing recipe signed off and alone, validated to the side, and you can run your new recipe on the side and validate it in time. You don't need somebody to change the PLC. You don't need somebody to go in and prove that the existing recipe is perfect and safe and not affected. You simply create a new recipe up at the upper level. And this goes for not just the flow or the sequence, which will be just a recipe system can do that, but batch management system can also change the equipment that you use. It can change the settings of the equipment that you use. It can change the sequence. You can do multiple of the same phase, one after the other. And it's quite powerful in terms of responding to customer demands and trying new batch types or small batch types. In a batch management system, that's the machine set points are automatically sent according to the recipe as well. So if your mixer, maybe you want to try in the chocolate cake example, maybe you want to try running the mixer a little bit slower. Maybe we'll get a better consistency if we run that mixer a little bit slower. And you can change that set point in your base recipe or create a new recipe with a different mixer speed. Maybe you're going to agitate a little bit slower. And these set points are sent from the recipe system. They're not dependent on an operator following your new SOP that you just drafted that day and having a big meeting with all the operators to explain to them how this recipe is very slightly different from the last recipe. And we really need to make sure that you follow it right. It's not dependent on you making sure the original batches aren't affected. No, the machine set points are changed just in your recipe up at the upper level, and they're sent to the PLC, and the PLC follows them. And yeah, I think the last point in this is pretty much the same thing. There's no reliance on the operator to fine tune the equipment to suit the new recipe. And by that, what I really was getting at is, in terms of the new recipe, if you run the mixer speed at a slightly slower amount, say a slightly slower mixer speed, you're not, say if you wanted to ramp it down rather than step it down from 100% down to 50%, say you wanted to ramp it down over 5 or 10 minutes, and you wanted to slow the mixer speed down, that can all be done within the recipe itself. You're not reliant on the operator to do it, and you're not reliant on an automation engineer to go into the PLC to code it for you. It's all within the phase itself that you can send the parameter set points to the PLC from the recipe itself in the batch management system. And the amount of time that saves is quite a lot in terms of automation hours to program PLCs or program whatever you're using for your recipe control. And it also allows you to get to market quite fast. It allows you to try recipes fast, and it allows your quality team to test your new recipes fast. And that's very important. And so as a result, Plant A in our example has a big advantage over Plant B. A bit about Neodyne. We're an engineering company based in Cork in Ireland, and we've got offices in 3 other locations in Ireland as well. So we have 4 offices in total in Ireland. We were founded in 1998, which is more than 20 years ago now. And we've got about 120 engineers and programmers at this stage, but they're based across 3 different divisions. Systems integration, which is the bit that I've just been talking about for the last little while, automation and that type of thing. But we also have fairly large divisions in power generation and utilities, but also in electrical transmission and distribution. We're an endorsed AVEVA systems integrator, which was something we're quite proud of. We worked hard to get, and we've got global multinational customers. Although the majority of our business is in the UK and Ireland and in Europe, we also have customers based around the world in North America, South America, and Asia. So we have customers pretty much worldwide. The Neodyne Systems Integration team, as I say, is the team that I'm involved with, and it's typically full end-to-end automation from instrumentation right through the PLC layer up through the Purdue layers to the MES layer, to be honest with you. And it's we're a turnkey solution provider as well, who provide into the, as it says in the slide, pharmaceutical, food and bev, power generation industries. And we partner with global tech companies to provide customers with leading edge solutions, as it says there. But what that means in plain English is we partner with the likes of AVEVA to bring good solutions to our customers. So if our customer has a need for a particular AVEVA product, we will endeavor to try and help them achieve good results with it.
Thank you, Brian. A very educational and informative session indeed. And thank you to C&D Foods and Adri van der Sand for helping us to share this great success story.